Welcome to the part 3 of the lesson on overview of inferential statistics. In this part, we are going to consider various hypotheses. The contents we are going to learn today is a discussion on framing the statement of a hypothesis, defining a null hypothesis, understanding the difference between null and alternate hypothesis, framing the null and alternate hypothesis for a given problem. Now, what is a null hypothesis? Answer: a null hypothesis is one that is capable of getting rejected. A null hypothesis is a falsifiable hypothesis. Consider the hypothesis: there are peacocks on the college campus. A, this is A. Another statement or hypothesis: there are no peacocks on the college campus. We have got two hypotheses. You cannot refute hypothesis A, or I should say there is no possibility of rejecting it. Why? If you do not see any peacocks, it does not mean that there are not any. Absence of evidence is not an evidence of absence, but B can be refuted. There is some possibility of rejecting it. A sighting of one peacock will reject hypothesis B. Until we see a peacock on the college campus, we work with the assumption that hypothesis B is true. Once we see a peacock, hypothesis B becomes false. Sir R. A. Fisher's theory: a null hypothesis is proposed and we look for evidence to reject it. Here the data gives a chance of disproving the null hypothesis. A hypothesis is rejected if there exists a sufficient evidence against the hypothesis, but we may commit the error of rejecting a true hypothesis. To guard against such eventuality, a test procedure is defined in such a way that we may commit this error with a small probability. For every test of hypothesis, a probability value is computed. This is an estimate of the probability that the current sample could have occurred by chance if the null hypothesis is true. If the probability value is small, we conclude that it is very unlikely to get the current sample. Hence, no support for the hypothesis. A large probability value means that there is no compelling evidence to reject the null hypothesis. For more clarity, we say do not reject H. We will never say accept H. That is the important point we should understand. Neyman and Pearson theory. This formed the modern statistics. Here we propose two hypotheses denoted by H and K. One is called the null hypothesis, again by H. The other is called alternate hypothesis K. If we do not find any evidence against H, then we do not reject H. Otherwise, we reject H, or equivalently we accept K. This approach helps one theoretically to compute the chances of committing errors due to incorrect decisions under hypothesis. How to frame null and alternate hypothesis? If we have a theory which is a deviation from the standard result or universal status, a current fact to be proved, then this one is taken as an alternate hypothesis. We denote by H 1 or K. Null hypothesis: a standard result or universal statement or normal result or a factual result which is capable of getting rejected, that is taken as the null hypothesis. We denote by H or H 0. Consider the following situations. A scientist may want to know whether the earth is warming up. A physician may want to know whether a new medication will lower a person's blood pressure. An educator may wish to see whether a new teaching technique is better than the traditional one. A retail merchant may want to know whether his customers prefer a new brand of product. An automobile manufacturer may want to determine whether automobile airbags will reduce the severity of injuries caused by accidents. In all of the above, a departure from a standard or universal statement is claimed. The claim is taken as an alternate hypothesis. The standard result is taken as the null hypothesis. Example: a firm has 15% of its business through the internet. Due to the recent spurt in fraud in online transactions, it expects a decline in business through the internet. We have two hypotheses. Proportion is equal to 0.15. Proportion is less than 0.15. Please note that the firm has 15% of its business. So, the current trend is proportion 0.5, but they suspect it goes down. So, second hypothesis, proportion less than 0.5. The first one must be taken as the null hypothesis. Example: suppose you want to ascertain whether there is any significant difference between males and females with respect to a particular learning ability. We have two hypotheses. One, there is no difference between the males and females. Two, there is some difference between males and females. The first one is the null hypothesis, and the claim, that is second one, is the alternate. Example: a telephone company maintains a call waiting service for 40% of its customers. Due to the changing market trends, the company feels that the percentage of customers who want this service is not equal to 40%. Of the two hypotheses, proportion equal to 0.4, proportion is not equal to 0.4. The first one is taken as the null hypothesis, the second one, the suspicion, is the alternate. Example: an engineer claims that his new innovation will lower the number of defects in a production process from the average of 75 per lot. Here H mu equal to 75 is the null hypothesis, and K, that is what the claim, mu less than 75 is the alternate hypothesis. Let us summarize the concepts we have learned in this part. A hypothesis is shown to be a statement. A falsifiable hypothesis is taken as the null hypothesis. The one that contradicts the null hypothesis is called an alternative one. According to Neyman Pearson theory, in case we cannot accept the null hypothesis, the alternative hypothesis accepted. A null hypothesis is never accepted, rather we say not rejected. Various forms of hypothesis for many situations are considered. So far in this lesson overview on inferential statistics, we have learned the process of gathering knowledge through observations. We also saw that the observation may contain errors due to the non-inclusion of some confounding factors and also due to chance. We described Karl Popper's theory of knowledge gathering process. We discussed the approach of proposing hypothesis according to R. A. Fisher and Neyman Pearson. We considered some examples of framing hypothesis. I hope that this lesson gave you the required foundations on inferential statistics. Let us meet in the next lesson. Thank you.